expressions to make them smaller. So the first thing that we're going to do today with 10-1 is look at expanding expressions. But before we do it, we're going to talk about equivalent expressions. What's it mean to be equivalent? Who doesn't have notes? You don't? That's why there's 3 extra copies. Wait, Mr. 10-1 or 10-2? So, everybody should have 2 sets of notes. Will everyone check if you have 10-1 and 10-2? Ella Jackson, hopefully you feel better. We have your notes here in class for you. Pranav, what's it mean to be equivalent?
Equivalent means to be like equal or like
to be equal, right? Now that the values end up equal, does it mean they have to be the same? Like, do they have to look the same?
No.
No. So like 2 of you, 7th graders, I guarantee we could find 2 of you that have equivalent weights. That doesn't mean that you're the same. This means that your weight is equivalent. So if I give you an expression, negative 21W, that's an expression. I want you on your paper, only using the tiles that you have on your paper, try to write at least 3 equivalent expressions to negative 21W. So you need to write 3 other expressions that will be equivalent to negative 21W. You can use parentheses, you can use addition, you can use multiplication. What do you need, Sheeb? 10-1. I figured you did, because I should only have enough for the class, and I had an extra 10-1. You can use parentheses. Now remember, if you use parentheses, that happens first.
Can W be anything?
Right now, yeah, because it's just a variable.
Wait, so if we have a W, then will we put the answer?
There is no answer.
But wouldn't W be the answer though?
W is an unknown value that represents something, but without this being equal to something, W can't have a value. Now, if I said this equals negative 42, then W is going to have a value. But right now, just it being an expression, W is just W. It might as well be a number, honestly.
Couldn't we just make it though to be that answer? It's just
Nope, because it's an expression. All we're working with is like 1/2 of the equation.
I'm thinking about it way too.
So Zach, what do you want to try to do?
So we can do 7 times negative 3. And then we can just switch that around to do negative 3 times.
Now, wait. 7 times negative 3, that would only equal negative 21.
W.
So you need W, right? Yeah. Now, I agree. So Zach was about to say flip it around, and we could do negative 3 times 7, and now my W could be on the 7 instead of being on the negative 3. Either way, both of those will end up being negative 21W. Pranav?
You could also do open parentheses.
Parentheses.
7 times negative 3.
7 times the negative 3.
Close parentheses.
Close the parentheses.
And put W.
And then the W on the outside. So we could group our multiplication in the parentheses. Lily?
Oh wait, are you doing an or can I do another one?
No, you can do another one.
Okay, so I made W equals 0, and
You can't assign a value to W.
Oh,
You are not. It just has to stay W right now.
okay.
You are like, all we know is that it is some variable. We don't know anything about it.
Okay.
No?
Negative 21 and a W, or no? I think
That's pretty much the same thing. I mean, I could put a multiplication symbol between and it's the same thing. What about some addition?
Wait, yeah.
Anyone use some addition? Nate?
Whoa. I got it.
You got 5 sets.
Sorry.
Seth?
Negative 21 plus W.
No, because that would be negative 21 plus the variable amount. This is saying we have negative 21 of the variable amount. Shahid? Yeah, we already pretty much have that. What if I do... We could repeat the addition over and over and over again until I have 7 of these. I'm going to run out of space if I don't, go up, down. We have 5, 6 of them, 7 of them. Close your parentheses, and then have your W out here. So there are many ways that we can write equivalent expressions. If we had division and subtraction also involved, we'd have essentially infinitely many ways that we could write equivalent expressions for this. Gravity works. So, first thing we're going to talk about here is the distributive property. I want to actually just jump to your notes to do this. The distributive property is how we take when there's a number outside the parentheses and we want to multiply, but we have to multiply by everything in the parentheses because what does order of operations tell me to do first? The parentheses. So can I add x plus 2?
Yeah.
Well, what's x?
Oh. No,
Well,
never
just
mind,
be
never
x
mind.
plus 2.
We don't know what x is, so I cannot add x. So since we can't do the parentheses, we move on with the order of operations, and we get to multiplication, but now it's 3 times a binomial, 2 terms in the parentheses, 2 different terms, so it's a binomial. So to do that, I want you guys up here on your notes to rewrite this and show, or over here if you ran out of space somewhere, or down there, or whatever. The first thing we always do, and I'm going to get really perturbed if people don't do this because you're lazy, is draw arrows. Each arrow there, Shahib, do you know what each arrow tells me to do?
Times it by the number.
Each arrow is essentially connecting a product, is connecting a multiplication. So the first product is 3 times x. The second product is 3 times 2. And that's how we then get to 3x plus 6, which is the value that they gave you right here. Wait. Formulate your question. Pranav, question?
Okay, so if it was like, say this is a completely different equation, but say if it was like 3x plus 6x, then you can
We can combine the like terms
Yeah.
first. Yeah.
Why do
But-
you need to do the arrows? Why can't you just do 3 times 2 and then get 3x plus 6?
It's to help you.
It's to show. It's so you can visually see what's going on.
But do you have to do that every time? Or can, like,
I prefer that at least for now, yes, because otherwise you will forget. Like I guarantee, at some point you'll make a mistake. Drawing the arrows will like help you not make that mistake. Because what I see more often than not is people do one of them and forget another one, or they do one of them wrong. So when I'm doing this, each arrow tells me a multiplication because I have to do 3 times the x and 3 times the 2. So then I just show that, and you don't even have to show it. You could have jumped right to 3x plus 6 because you know 3 times x and 3 times 2, and we get there. Now it has another example for you here. What if it's negative? Doesn't matter, does the same thing. So the negative 2 distributes to the negative 3y and to the 5. So we have negative 2 minus 3y plus, because there was addition between them, we keep the addition between them. The negative 2 times the 5, we do the math. We still can't add them. So we just end up with 6y minus 10. Questions on how we distribute?
No.
wait, why is it 6y minus 10?
Because it was negative 2 times the 5, and that gave me a negative 10. So instead of writing plus the negative, they just made it subtraction.
Oh, okay.
Because it's simpler. You use one less symbol. So we want to find an equivalent sum or difference for each product. So the first thing you should do,
Add the arrows.
draw the arrows. Now, here is one other thing, and that, Zach, you might like this better. Sometimes we'll put one arrow on top and the other arrow on bottom. Some people like that better because then they show their work by doing a times 2 up here, a times b down here, and then when they put them together, they just say, well, so instead of saying a times 2, we like it better when the number's first. So we'll say 2a, grab the addition from between them, plus a times b. Try the next two on your own. I actually kind of more and more like doing one arrow on top and one arrow on bottom. So as long as you have an arrow going to every term in the parentheses, you're fine. All right, Grace, can you tell me what we get from our first multiplication there in blue?
5.
Yeah, the 5 times 1 gives me 5. Ella is absent. Nate, what about my other multiplication there in blue?
5 times 4c.
Which gives me?
20c.
20c. So then when I put it all together, Ashton, what do I get?
You get 5 minus
5 minus the 20c because we had a minus between them. Now, Olivia, this one gets a little bit more challenging. What's my first multiplication in green?
Negative 2/10 times 7x.
Yeah, which gives me?
1.4x.
So I'm going to write this one out because it's a little bit harder to see. So that's our first multiplication, and Olivia told us it gives us negative 1.4x. Our second multiplication, Shahib.
It gives us negative 0.06.
So we do negative 0.02 times the 0.03. Now here's the trick, and you have options, and math always gets harder with the more options you have. You can either look at this as minus 3/10, or you can look at it as a negative. It depends on your brain which way you're going to think is easier. If we take it as a positive, I get negative 6/100ths. Actually, I didn't remember if you said 6/10 or 6/100ths. But then there's a minus between these two. So it actually ends up becoming negative 1.4x plus 6/100ths. So you should have negative 1.4x plus 6/100ths. Anyone confused on how we got there?
Oh.
Because we took this as a positive 3/10. So the negative, so we essentially broke that up. We said this is positive 3/10 and there's the minus that was between them. Question, Shiv? Think about the got it for a moment. And it helps if you solve it. Which of the expressions below, and it could be more than one, is going to end up equivalent to the expression shown here? So if I look at solving this expression shown here, sometimes I like to, especially if there's addition, I'll just do it like this. So what's negative 1/5 times negative 5m? Well, 1/5 of 5. That just gives me m. Negative 1/5, positive 10. Zach?
Wait, can I do the answer?
Oh, yeah, sure. So this gives me negative 2. So what do you think the answer is, Zach?
3. Or the third choice, sir.
It is actually
Oh,
not.
I meant the second, sorry.
Yeah, the second one,
Because,
because the m became positive, the negative times the negative. So that's how we got the positive m. The 2 was negative because the negative times the positive. Is there any other expression up there that would be equivalent? Really?
3?
Negative m, positive 2. We
Wait,
can't
no.
change the signs of
No,
those.
never mind.
Pranav?
The first one.
The first one. Think about it. Negative 1/5 times 10 gives us that negative 2. Negative 1/5 times the minus 5m or the negative 5m will give us that positive m. Question? So both of those are equivalent. We got to speed up just a little bit, so we're going to whiz through this last part. All you really need here, and this got it, what's the difference between what's happening here? What do we have when we have a parenthesis right up against a parenthesis? Karen? Multiplication, right? What do we get when we have a parenthesis that then is followed by a negative y? Well, okay, you already said it out loud. Say it louder.
Subtraction.
Yeah, it's actually subtraction.
So then does the y lose its negative?
So this is actually minus y. This is negative y because it's going to multiply. I only said this as a negative y because you can really always look at it either way. A subtraction is like adding a negative quantity. So I just wanted you to kind of have to process through, because this has the operation after the parentheses, it doesn't multiply. If you wanted it to multiply, you have to put it in parentheses, so you have parentheses right up against parentheses. We have an architect drawing plans for an expanded patio. The patio was 3.7 meters by 4.5 meters. It was that space. We're going to add on a new addition that's going to be x meters long and the same meters wide, or taller, however you want to phrase that. So what does each factor in the expression represent? This is going to be part of your homework, where it will list out like 3.7, 4.5, and x. What are these things? So 3.7, Pranav, what's the 3.7 represent?
The 3.7 represents pretty sure
The entire what?
Pretty sure the 3.7 like is representing the amount of
So let's say there's a door here. You walk out on the patio.
Yeah.
Say when you walk out on something, when you look at this, what do we call that normally? The width. So the 3.7 would be the width of the patio. That then would make the 4.5. James, what would the 4.5 be? If this was our width, what's this?
Length.
Our length of our patio. GTH. What is going on, Hudson? And then X. Noah, what's the X?
It's gonna be the length of the addition.
Yeah, so it's my additional length. You can abbreviate additional by ADDTL. I don't know why. You just can. Then, if we use the distributive property, well, we would distribute 3.7 to 4.5 and 3.7 to x. But what do those things really represent? So if we do 3.7 times 4.5, do you have it? It's 16.65. And then what's the other multiplication give you?
3.7x.
But what are these values? Shahid?
The first one is the area
Of what?
of the first portion that's already.
My first distribution gave me this area of the patio. My second distribution, go ahead and finish us out, Shahid.
Gives you the area of the extended part.
Gives us the area of the addition. So as soon as I decide how long my addition is going to be, then I'll know what the new combined area is. Questions, comments, concerns? Do you think we are good on this lesson to skip the final got it, because it's essentially the same thing?
Yes,
Yeah, it is essentially exactly the same thing. All right, so moving on to 10.2. We are going to skip our lunch, I believe. So when we talk about equivalent expressions, there's lots of different ways to write them, and we just saw about how we distribute to get there. Now what we're going to do is the exact opposite, and I think we'll actually be more effective with our time if I just jump over here. So look at the intro. Rewrite the 5 times 2x plus 9 as a sum. Let's see how well you did with your distribution. So don't even look at the right part yet. Just do this. We want to do the distribution, rewrite it as just one term plus another term. So Peyton, what does that first multiplication get you?
10x.
10x. Carrie, what's that second multiplication get you? 45, right? So now, when we look at the right side over here, I have to slide all this over. Oh, come on. So I'm just going to slide these over, and you guys know what we're talking about. Rewrite 10x plus 45 as a product. What this is telling you to do is factor. So there's a very specific way I want you to do this on your paper. Otherwise, I would call on you guys. But when we look at factoring, we're looking at the numbers. Well, not the numbers only, but primarily we're looking at the numbers first. Then we look at the variables. But since we only have one variable, ignore the variable right now. This should be a very easy question. What common factor could we divide out of 10x and 45? Class? 5. We're doing the opposite of what we just did. So what you want to show is division by 5. So draw that on your paper right now, please. And then that 5 is actually going to travel to in front of our parentheses. And what's going to fall in our parentheses will be the 10x divided by 5 and the 45 divided by 5, which then gives us 5 times 2x plus 9. That's all you have to do to factor is the opposite of distribution.
That doesn't seem shorter though.
We're not trying to be shorter. We're trying to look at when you have an expression that has common factors, how do you pull out the common, like whatever's common between both of them, or all of them if there's more than 2. Chief?
Would you find like the greatest common?
Yeah. Here there was only one common, like 1 would have been a common factor also, but that doesn't make any sense. Pranav?
Wait, so for after like expressions, if we have equations and we have a variable in them, can we find the variable?
So factoring is one step that's going to lead us to how do we solve equations more effectively. Yeah. So I skip right to your key concept. That's also why I'm not following the digits lesson. So our key concept here is just looking at the difference between expanding and factoring. So since we just did expanding with the distributive, I feel like we can breeze over that. The only thing you could add here is the arrows if you wanted to. And then it goes through and shows the multiplications. So when we factor, a good trick for factoring is look at your smaller value. So when you look at factoring 15x plus 21, well, I need to look at the 15 and the 21 looking for a common factor, but a factor in 21 that's not in 15 won't help me. So look at the smaller value, think of the factors. What factor of 15 is shared with 21, right? 3. It's already on your paper and it's not too hard to figure out. 3 is our common factor. So here's how I do it. It's a little differently than what Digits does it. I, at least in my head, think about the fact that I'm going to divide this by 3 and that by 3. You can write it as one division line or 2 separate ones. It doesn't make a difference. So then I have 3 out front. The 15x divided by 3 gives me my 5x. And the 21 divided by 3 gives me my 7. And that's how I get to my factored form. Huh? I'm just swapping pens and everything else. Yeah. And my blue, the tip of the pen is getting mashed in. I think I might buy some more pen tips because I use blue so often. Olivia?
Do you have to write out that division thing?
No.
Okay.
I just do it so that you guys see everything and understand everything. Digits likes to show it by breaking up the coefficient into the product that involves the common factor. This is another way that you could write it. So instead of showing the division, they show that the multiplication of 3 exists in both terms. So they go ahead, and then when you get rid of those 3's, all you have left is the 5x and the 7. So another way you can do that. And like terms. What does it take to be like terms?
Is it like equal terms or similar?
Pranav, what do you have?
I'm thinking for like terms, those the two numbers have the same variable.
Same variable. There's one other thing you have to look for.
And they have
And it doesn't even say it here.
and
That's
have
why I
the
was.
same sign.
I don't know what you mean by sign.
No.
Shaheed?
By,
Like terms are when they have the same exact term,
Here on your notes, you want to write same variable. What else?
like they have the same exact
If I'm a number, it's right up here.
variable power and exponent.
Same exponent or power. Same variable. Actually, since power is easier to remember, same variable, same power. Now, a lack of a variable, having no variable, is the same thing as having a shared common variable. So, no variable is really like the variable of 1, or like the multiplication by 1. So 1.8a and 0.4a are common factors because they both share a to the first power. So essentially, why we want to look at factoring is when we combine like terms, we are pulling out that common factor of a, adding the numbers together, and then putting it all back together. For now?
so that's not how it works for multiplication.
What, like terms?
Yeah.
Like terms don't matter for multiplication or division. Because think about it like this. If I give you 3 widgets, a widget. You don't know what a widget is, but I hand you 3 of them. And then I say triple your amount of widgets. How many widgets do you have? 9. If I hand you 3 widgets and I say, hey, add 2 to that. You're like, add 2 what? Add 2 pizzas, add 2 cats. I'd have to give you 2 widgets to add to it. If I just tell you to add 2, like, if I give you 3 widgets and 2 whoozits, you now have 3 widgets and 2 whoozits, and you have 5 things all together, but you can't combine the widgets and the whoozits. They're not the same. Right? Like,
It sounds like a Dr. Seuss book.
I read a lot of Dr. Seuss as a kid. I might still read it as bedtime stories right now. So, Peyton about had water come out her nose. Alright, so this is what your homework is going to look like. Starting out, they're going to give you parts of it. So, my first expression up there, 8a plus 4, they give you the common factor. So I want you on your paper right now to show that we have divided by 4, and that's why 4 is the common factor. Right. Since we divided by 4, what will the terms in my parentheses now be?
2a plus 1.
Yep, 2a plus 1. Leah, my next one, we're actually going to work down here, gives you what's in the second parentheses, but it doesn't give you the common factor. So can you look at 3.5m minus mn and tell me what's common between both of them? Yeah, it's m. Because I have an m in this factor, and m in that factor, and because this only really has a 1 in front of it, we're not going to divide by 1 because it wouldn't make any sense. It wouldn't do anything. So we just divide by m, and that becomes my common factor. Try the next 3 on your own. I'll give you about 30-ish seconds probably.
30-ish.
And that'll give me time to shuffle. If you didn't get called, it means I talked to you otherwise, and then I skipped your card. Alright, that was about 30-ish, probably more. Zach, when you look at 14x plus 21, what's a common factor? The greatest common factor. 7, and actually there was no other common factor. So that comes out front, and then what do you get inside your parentheses?
2x plus 3.
Yep, 2x plus 3. Grace. Wait.
Why is it 2x?
Because, so, great question. Thank you for stopping us. When we divided this by 7 and divided this by 7, so 7 doesn't have a variable, so it doesn't goof with the variable. It doesn't do anything to the variable. It only affects the number. So 14 divided by 7 gives me 2, and the x just kind of comes along for the ride. Because if I gave you 14 widgets, and I said, now divide your widgets by 7. You make 7 groups, and I say, how many widgets are in each group? 2 widgets.
Okay.
Yeah. So that's like terms can multiply and divide. Non-like terms can multiply and divide. But when we get to addition and subtraction, only like terms can add and subtract. Grace, you almost slipped out. Y minus xy. What's the common factor?
Why?
Because I asked you, what's the common factor? Ha ha ha. Yeah, y is the common factor there.
You have to add laughter on the video, Mr. Hudson.
Yeah, I should have a laugh track.
Now you have to edit the video with us like laughing and
Like, ha 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 ha.
Yeah, and upon laughing.
So, here's where people goof up. Grace, what then is inside this parentheses? What would y divided by itself give you? Any number divided by itself? 1. So then xy divided by y, then these y's cancel each other out, and we get just x left. That's where people will make their mistakes. A value, whether it's a number or a variable, doesn't matter. A value divided by itself is always 1. So this y divided by y in the xy really becomes 1 when you do the y divided by y. So you get 1x, but we don't need that 1, so we don't write it. We want to keep things a little bit nicer. And Leah, this one's harder. 12a plus 16b minus 10c, they give us nothing. What's a common factor we could divide? What is it? So I can't see you when Lily's head is in the way, so that's why I have to move when I talk to you. 2! They're all even, so I can divide all of them by 2. Don't even try to mess with the variables, because I have 3 different variables there. So 12a divided by 2. Well, this 2 needs to come out front. What's 12 divided by 2?
6.
6, so we get 6a. 16 divided by 2? 8, so we get 8b. 10 divided by 2? So we get 5c. Yeah.
What kind of loss is this basically just simplifying?
Actually, it's kind of unsimplifying. So it's saying what is common between all of them that we can pull out of it through division.
Why do we do it?
It'll make more sense later. Like, the main reason we do it is right up here with combining like terms. When we combine like terms, we are actually having to use factoring. We don't actually write out the process, but we are doing factoring because we say the a is common to both of them, so I pull out the a. Now I can do the addition of 1.8 and 0.4. So once I add those, then I switch the order back around just because we like it to be the number first. So anytime you're combining like terms, you're actually using factoring.
That's like the third time.
Yeah, I know. I do it a lot. 12x, 42y minus 3. Here's one of those times when looking at the smaller number will very much so help you quickly identify the common factor. Rye, what do you think is the common factor between these 3 terms? 3, because 3 is only divisible by 1 and 3. So since we can only divide that by 3, we divide that by 3, and we also divide that by 3. So, yeah?
What if the 12 was something like 13?
Then there's no common factor, and it cannot be factored. Yep. Then you just say you can't be factored. It's in simplest form or whatever. So my 3 comes out front. Carry 12x divided by 3. 4x. Then we bring in the subtraction between them. L6. Pranav, 42y divided by 3. What's 42 divided by 3? It's one of the harder ones because it's up above. It's up above 10, so a lot of us forget these. 14, calculator cheater. And 3 divided by 3, class. 1. Don't forget to put the 1 in there.
7.
All right, real quick review of like terms. Here, again, I want you to write same what? And same what? power, same variable, same power. Yeah, I know. There was like some Thanksgiving parody of it that I heard like 8 times, and it drove me crazy. So, examples. Examples, like terms. If I have x and x, same variable. Stop, because you need to see this. When you have multiple variables together, they essentially make their own new variable. So xy, you can look at as one variable because they're combined together. So to be a like term, it has to have the xy multiplied together. If you have xy and then you just have x, they're not like terms. I know they share the x, but there's no y over here, so they're not like terms. Don't scroll. And then with the power, x squared would be like terms. X squared and x, a lot of people make mistakes here, not like terms. Because here, this is like having the area of an object, and this is like having the length of an object. Because once we square something, we're talking about area. Olivia?
So it has to have the same variable and the same power, but like, are the variables connected to the numbers?
Yeah,
Like,
through multiplication.
Okay.
But the coefficient on it doesn't make a difference. So if you had like 2xy and just xy, well, that's really one xy, and I mean they are like terms because the variables are the same. Make sense? Okay.
That's all the boys.
Huh, that should not have captured. It should have cleared. Stop. All right, which of these has like terms and can be combined? Karen, left or right? Which has like terms can be combined? The left one, because this has a constant and a coefficient. Now, negative x. What number's really in front of a variable no matter, like if there's no number, what number's really there? 1. So this is really negative 1x plus 3.5x. So, class, what do I get when I sum negative 1 and 3.5? Yeah, somebody started saying it, 2.5x. Now, here's another, hey, I only have a minute left. I don't want to have to keep you guys late. Here's another place where we use it in real life. If you are working in a store and you want to increase prices, if you increase a price by 3%, you can just take the original price plus 0.03 of the price. When we combine those, we could really just do 1.03 times the p. That's all we have time, so we'll finish this tomorrow if we need to. Your homework is posted already. I will see you guys later.
Nah, dog, you're gonna stay here.